Hi, I'm Brian DeHoyas. I'm here with the EV team here to explain our ventilation system. Here we have an air filter that pushes in air and brings it out through the bottom of the box. The purpose of this ventilation system is that it cools the batteries down as well as maintaining maximum performance and lifespans of the battery, reducing those heat cycles. Now if you can come over here, this is our control box. We have a 3-position switch. If you position the switch to the left, we now have manual control of the fan. And you see down below, now when I move the switch all the way to the right, we are now in our thermostat control. And here's an example of the thermostat working. We put a heat gun to the thermostat, and we estimate about between 140 to 150 degrees where the thermostat kicks in. This may take some time as we are just heating it up. As you can see, down the fan has now turned on. And then when the thermostat cools off, then the fan will also turn off. And then you just put the switch back in its neutral position in the middle, and it turns the thermostat off completely. I'm David Caprera with the EV conversion team. I'm going to talk about our ventilation system that we incorporated into our containment system lid. We have the blower right here, which draws outside air in and directs it up into our lid / plenum. The air collects in this lid. It's a 1-inch void in here, and then it directs the vent air over each of the batteries through these holes. The air is then swirled in here and through the partition, through the louvers down there. The vent air goes to the controller side of the containment system and then finally escapes through the bottom of the box.
Hi, my name is Caitlin Hanks and I'm with the EV conversion team. I'll be explaining to you the structure of our containment system. On this side we have the batteries, and underneath the batteries are square aluminum tubing, and it raises the batteries up, allowing for extra support and stability as well as allowing airflow to go under each battery. We also have angle aluminum framework, and that keeps the battery stable laterally, with the flat bar aluminum acting as hold downs on top of it to keep them in place whenever the vehicle is in motion. On this side of the containment system we have a partition wall splitting between the batteries and the controllers. And the controllers also have the same square tubing under them for support, and they're on T-tracks to keep them in place and held down, and then for easier access to remove them and move them around when needed. We added the seal around the box, which lines up with the seal of the plenum lid, keeping it airtight and allowing no air to escape from the box that we do not want. Thank you.
Good afternoon. My name is David Glasson, and I'll be talking about the electric power drive system for our project. I'm going to give a brief overview of it, and then I'm going to go into a little bit more depth of the process itself. So, with an electric vehicle conversion, we're going to need an electric power source, and that's what this is here. And from there, we will provide power to 2 motor controllers, which can be these 2 black components here. And then that will provide power to our motor, which will be connected to the transaxle, thus spinning the tires. Now I'm going to go over to a little bit more detail of each process. So for our battery, or for our power source, the team decided on a design of 8 12-volt lead-acid batteries, which comes out to 96 volts, which is necessary to power the entire drive system. From the batteries, we will send 96 volts to the motor controllers. They will read the input, and then from there they'll output 48 volts to these 2 contactors. Once these contactors have recognized the 48 volts, they will switch on, and then a separate part of the controllers will convert the 96 volt DC into 96 volt AC. And you can see that here on the controller, that we have the input of the DC right here on these 2 terminals, and then it will output the AC on these 3 terminals. 1 phase per terminal, thus creating 3-phase AC. And from here, they'll travel to the motor and provide power and also communication to the motor, telling it to either spin forward or reverse. And that concludes the demonstration of the drive system for our project. Thank you. Go.
I'm Brandon Shepard with the EV Conversion Project. I'll be taking you through a full demonstration of the drive system, just going all the way from the control panel to ultimately driving the wheels and the transaxle. If you want to come over here, you see the control panel that we built. This is going to take the place of a full implementation on a vehicle. However, this will be all of the components and accessories that are going to be needed to facilitate said run. So with that being said, what we're going to do is we're going to first turn on the system, and the first thing you're going to do is you're going to hear the contactors engaging. And those are them right there. So the number 1 and number 2 contactors that ultimately provide power up to the motor, or to the controllers, to the controllers, have now been energized. I'll take you through this real quick. These are our indicators. This is for controller 1 and controller 2, and this is how they will communicate with the operator of the system. And we have various things that we can run through here. So we're showing a voltage of 100.2. Right now, as all 8 of our batteries are fully charged. Motor temp, controller temp, and those are just minimum and maximums that we can run through. And then those are RPM that each controller is going to sense coming off the motor via our CAM module. So what we can do now is we select a forward direction for our motor to drive, and then this will be our throttle. As I manipulate the throttle, ultimately what's going to happen is power will be applied to the motor. The motor will turn the transaxle, which will in turn turn the wheels. So cameraman, go ahead and point up to the wheels, and I will go ahead and throw the throttle forward. And as we will see, the motor starts turning and the transaxle now turns. So this will be a forward direction of the vehicle. The transaxle we have currently locked out in 3rd gear. So we have basically a 1-to-1 turn ratio of motor to tire rotation. And right now we're sitting at about 400 RPM. And we take this up higher, we can run it up to 1,000. The motor has a full rating capacity of 6,500 RPM. So right now we're sitting at 1,000 RPM, and for this purpose of this test, and as far as safety procedures go, this will be where we stop. We can obviously go higher than this. So what we'll do is we'll go ahead and let it wind down. We stay on this control panel, and we go ahead and select this reposition switch. We can go into reverse and then go back up to the tires. So using the same throttle in the same manner, we go and now reverse. And we'll go ahead and shut it down right there. And then we come back here and we'll just go through the shutdown sequence, put that back into what we can call a neutral setting, and then disengage and turn our system off. Thank you.